This is the video on exponents. Here is an outline of what we will be looking at in this brief review. We'll be looking at the possibility of using 0 as an exponent. We'll be looking at negative numbers as exponents. And we will also consider some of the exponent laws and how they're used. So as you know, for positive whole numbers n, a to the n, a with the superscript n, pronounced a to the n, is shorthand for multiplying n a's, n factors of a. So for example, 5 to the 4th is shorthand for 5 times 5 times 5 times 5, which if you multiply out gives you 625. Here are three laws for exponents that are fairly obvious, laws that you're also probably familiar with. The first law is that if you're multiplying two powers of a to the n times a to the m, you can rewrite that as a to the n plus m. When you're multiplying two powers of a, you can add the exponents. And this is fairly obvious if you look at a simple example. Let's try 2 to the second times, let's try a to the second times a to the third. So before I go on, I just want to mention that a to the second is sometimes pronounced a squared, and a to the third is sometimes pronounced a cubed. And I may do that throughout this video. All right, a to the second is shorthand for multiplying two factors of a. And a to the third is shorthand for multiplying three factors of a. And now if we count the total number of a's that are multiplied here, we have 2 plus 3, which is 5, and the shorthand for multiplying 5 factors of a is a to the 5th. Second law, if you have a power of a raised to a power, a to the n raised to the m, you can rewrite that as a to the n times m. You can multiply the exponents. And here again, if we look at a fairly simple example, we can see why this works. We're going to try a squared, or a to the second, raised to the third power. So when you raise something to the third power, that means you're multiplying three of those things. A squared to the third is shorthand for a squared times a squared times a squared. And each a squared is shorthand for a times a. And now if you count the total number of a's that are being multiplied here, we have three groups of 2. And you get 3 groups of 2 by multiplying 3 by 2. This is a to the 6th. The final law that we will be looking at in this video is what you can do if you have two powers of a divided. A to the n divided by a to the m. And in this situation, you can subtract exponents. A to the n over a to the m can be rewritten as a to the n minus m. Another simple example will show us why this is true. We're going to try a to the 5th power divided by a to the 3rd power. So the numerator is shorthand for multiplying 5 a's, and the denominator is shorthand for multiplying 3 a's. And the 3 a's in the denominator will cancel with 3 of the a's in the numerator. So to get the total number of a's, we're subtracting the 3 a's in the denominator from the 5 a's in the numerator. This will be a to the 5 minus 3, or a squared. Those were positive whole number exponents. Now, what about an exponent 0? What should a to the 0 be if the laws for exponents are going to hold? Well, looking at a simple example will tell us what a to the 0 should be. We'll try a to the 0 multiplied by a to the third. So if the laws for exponents are going to hold, this is the situation where you add exponents, so this should be a to the 0 plus 3. And 0 plus 3 is 3. So a to the 0 times a to the third, if the laws for exponents are going to hold, should be a to the third. Which means that a to the 0 is the number you multiply by a to the third to get a to the third. And there's only one number that does that, namely 1. So a to the 0 is defined to be 1. It's defined that way so that the laws for exponents will hold. Negative exponents are defined using similar considerations. So let's look at a to the minus 3. What should a to the minus 3 be so that the laws for exponents will still work? We'll try this example. A to the minus 3 times a to the 3, if the laws for exponents are going to hold, should be a to the minus 3 plus 3. Minus 3 plus 3 is 0, so this will be a to the 0, and we've decided that a to the 0 is 1. So a to the third is a to the minus 3 is the number you multiply by a to the third to get 1. And there's only one number that does that, namely 1 over a to the third. This is the number which, when multiplied by a to the third, will give you 1. And in general, for negative exponents, minus n, a to the minus n is defined to be 1 over a to the n. It's defined this way so that the laws for exponents will continue to hold even if negative exponents are allowed. Okay, let's try a few examples using the rules for exponents. 3 to the 8th times 3 to the minus 5th. Here we are multiplying 2 powers of 3. This is law number 1. You add exponents in this situation, so this can be written as 3 raised to the power 8 plus minus 5. And 8 plus minus 5 is 3. Final answer, 3 to the third. Same kind of problem. This is law number 3. When you divide 2 powers of a, you can subtract exponents. So a to the 10th over a to the minus 2 is a raised to the power 10 minus a minus 2. 10 minus a minus 2 is 10 plus 2, and so the final answer is a to the 12th. And finally, simplifying x to the 6th to the third. This is the situation where you multiply exponents, so this will be x to the 6 times 3, and 6 times 3 is 18, x to the 18th for a final answer. I want to say a few words before the video ends about multiplying a decimal number by a power of 10. So we're assuming on this slide that n is a positive whole number. 1, 2, 3, 4, and so on, one of those. So how do you multiply a decimal number by 10 to the n? As you probably know, you move the decimal point n places to the right. So for example, 10 to the third multiplied by 43.3 can be written in decimal form by taking the 43.3 and moving the decimal point to the right 3 places. In order to get 3 places, I have to add some zeros on the right of 43.3. And now we actually do the multiplying. So if you move the decimal point 3 places to the right, we get an answer of 43,300. What about multiplying by 10 to a negative power? Well, as you probably know here also, this will move the decimal point n places to the left. So for example, if you multiply 10 to the minus 3 by 43.3, this can be written in decimal form by moving the decimal point to the left 3 places. I have to insert a 0 on the left-hand side to provide the 3 places that I need. So this is 10 to the minus 3 times 043.3. And then moving the decimal point 3 places to the left gives me my final answer, 0.0433.